Hello, my name is Thales Korting and I'm going to present how spatial filtering works. The basic thing about processing digital images and apply a spatial filtering is to run on every pixel of the image. Here we provide an example of what we call a window or input window, and here we have visualization of intensities of each pixel in this small window. The basic idea is to get this value here represented by the center of the input window, and we apply what we call a filter or mask or a kernel or a template window with several weights. All these weights here are related to one of the input values of the input image. The main idea is to make a computation between all the original values and also the weights here, that depending on the configuration of this filter here, we will have a different output. And how we make this computation? So this x will be computed, this first value here will be multiplied by this first weight here, and it will be added to the second value plus this weight here plus this value multiplied by this weight, and so on. Each line here defines one of the pixels in the filter multiplied by one of the weights here. And then in the output image we will get the result of this sum and we'll put in the output image here, replace this pixel value here with the result of this equation. Depending on the weights here, we will have a different output. And in this video I will provide two examples. The first example is what we call a high-pass filter. The high-pass filter means that it will highlight only the high frequencies. Suppose we have here the input image in this animation that I provide here, and then all the pixels inside this window are highlighted here, and also the current value is highlighted by this moving window, this moving rectangle here. Here we provide a three-dimensional visualization of the input window and also a three-dimensional visualization of the filter. So all the weights here are defined according to this equation. The center here has a high value, the number is 9, and all the neighboring pixels have a value of -1 as represented here. We applied the calculation that I provided previously, and the calculation is get this input value multiplied by this input filter, and here I put the partial result. And as long as we get the multiplication here, we will see the differences between the input value, which is this x here, and the output that is produced by summing all the pixels in this mask here. So a high-pass filter is a configuration of weights that aims to highlight the high frequencies. In this example image here, where do we have a high frequency? We have in this line here, because we have a subtle change between the line here and then a subtle change. And so this line will produce a high output in the filtering result. So we can see here. And all the low frequencies or the differences between pixels here that are not so strong, they will not be referred here. And now I provide what we call a low-pass filter. Is a different configuration of weights that aims to create an image represented by the low frequencies. Here we have a low frequency when we change slightly from white to black, and in this point which have a high frequency, this high frequency will not be outputted in the low pass result here. We can define all the points with the same weight and all the weights are defined by 1 divided by 9, which can be also considered the average of the pixels in the window will be delivered as output. I have the same thing here, the current input window, the 3D visualization of the input window, the 3D visualization of the filter, and the partial results that are being computed by multiplying this value by this weight and so on. What we can see in the result here is that the high frequency defined by this line here is not appearing here anymore. So the aim of the low-pass filter is to remove the high frequencies, and the aim of the high-pass filter is to emphasize the high frequencies. So the main reference that I've used to create this video is the well-known digital image processing book by Gonzalez and Woods, and this is how spatial filtering works. Thank you.